Here in 4.2, we start describing something that is part of the core experience of why we have coding languages in the first place, and that is to repeat things for us so that we don't have to hard code everything. So looping is one of the built-in advantages that computers give over just you and I being there to write down math or to write down a procedure is, we do those things and we are very, very error prone. Whereas as long as our logic is good and our math is good or our procedure is good, a computer can do a loop, doing something again and again and again and again and again until it has to stop, with two things. Number one, reasonably high accuracy, and number two, reasonably high frequency, so it can do it really very, very fast. So the first loop we're going to look at here is the while loop, and this starts on page 194. So the way a while loop works is as follows, and we'll get into the keywords and we'll get into some of that in just a moment here. What happens is, up at the very top of the loop, we test a condition. Now, a condition can mean a whole bunch of things. It can mean math. We can test for, is X greater than Y? That's a mathematical statement, and that's something very easy for code and a machine to be able to check. We can check for equivalence. So we can check for equality, equals equals. Does X equals Y if they're both characters? So is it a Y for yes or N for no? We can check that. We can do, the same way we would have in the previous chapter 3 with a switch statement. We can check for equivalence in that way. If X equals and then the character A, we can continue through a loop. The important thing to know about a while loop is the condition is checked for truth up at the very top. So that means you are responsible as a developer for creating a situation where the loop can even be entered into in the first place. So we call that a priming read. Would you like to continue? Yes or no? So once you get that answer, you can test for, yes or no when you get into the while statement. So we'll see how that works, and we do have videos and code samples later on so you can see how all of this works. But it is really the easiest of the loops for you to have to manage from a beginner's perspective, because you control whether or not you even enter into the loop at all. So usually, this is just like a pro tip. Usually, if you're like, why isn't my while loop being executed on? It's because you didn't do something that would have enabled you to get into that loop in the first place. So really, here we go. Scroll down here to code listing 4-3. It is on page 195. And you can see we've got our while structure. So we have here inside of our main, we are declaring an integer variable called number, and it is equal to 1. And then here on line number 11, this is where our code is. We are saying while number is less than or equal to 5. So before we even go into here, let's think, how many times do we think that this code is going to execute? How many iterations through this while loop are we going to go before it actually quits? Is it 4 or is it 5 iterations? So it's 5, right? Because we have less than or equal to 5. So 1 is less than or equal to 5. 2 is less than or equal to 5. 3, 4 is less than or equal to 5. And the next time we come through, it's going to check again. Is 5 less than 5? No, but it is equal to 5. So then we can go through for our 5th loop through that statement. So what essentially happens is this. We enter here into line number 11 and we check this condition for truth. Is number 5 less than or equal to 5? True. You can continue down through this statement block. Remember, a statement block has the curly braces there. That's how you know as a developer, and that's how Java knows these statements go with this while loop. We print hello, and then here number plus plus. This is the payoff for having the increment and decrement operators in 4.1, the previous video. What this loop needs to have is a way to test for truth, but we also need a way to be able to get out of this loop in the long run. We need to be able to increment that counter, and we're using number as a counter to be able to get out. So if I do not have this number plus plus statement here, I am never going to break out of this while loop because number will always be less than 5. The condition will never test false. So that's where it's incumbent on you as a developer. And this is actually one of the things that I do as a developer, having stepped in this. Anytime I make a while loop, I immediately start the statement thereafter with a statement block. So my opening and closing curly brackets. The thing I do immediately thereafter is I put in my increment plus plus. So in this case, it's number plus plus, because guess what? I have built numerous infinite loops. That's what it's called when you cannot get out of a while loop, is an infinite loop. And I have built lots of those. And now I know, oh, I'm building a loop. Let's make sure I can get out of it. So it's the very first thing I do is start at the bottom of that loop essentially and give myself a way to leave. And then I build the rest of the statements that go along with that. So the while loop, remember, needs you to provide a priming read, some way for us to get into the loop. But it also needs some way for us to get out of the loop. And we would do that with an increment or a decrement statement. Don't try to get too fancy and complicated right in the beginning. Most of us use count up instead of count down timers. It's just more logically, like normal, I think, to do it that way. So you will far more often use number plus plus than you will use number minus minus. But that is the while loop. We enter in and we stay inside of that loop so long as the condition is true.